Have you ever gazed at the night sky and felt awe? Are we alone in the universe? If I told you that roughly 99% of space is just empty void, and the remaining 1% remains an unsolved mystery, then right now, a milestone event is unfolding. After weeks of perplexing silence, driven by pressure from the scientific community and intense public curiosity, NASA and the European Space Agency have finally released official high-definition images from the Mars flyby probe Target 3. As a scholar who has dedicated half a century to theoretical physics research, I must admit these images carry immense uncertainty. My understanding of possibility is becoming profoundly fragile. These images not only challenge our existing knowledge of comets and interstellar objects, but also force us to re-examine the boundaries between natural phenomena and man-made artifacts in the cosmos. This is far from a simple discovery of an object. It could indicate the presence of some tool, some probe, or it might fundamentally rewrite our understanding of the nature of cosmic life. These images were officially released yesterday in October. No grand unveiling, no press conference. It was simply uploaded to an AS planetary data system. As night fell, amateur astronomers, observers, and professional scientists worldwide began downloading the data almost immediately. What they discovered was a court tremor. Through a global scientific network, the Mars Reconnaissance Orbiter (MRO's) high-altitude camera, the most advanced telescope ever deployed beyond Earth, captured 3 images. This October, I flew past the Sun aboard the Atlas probe. At a near 18 million miles from the Sun, the resolution allowed us to discern details smaller than city blocks. These details were unlike anything we'd seen before. Let me explain why these images are so unsettling. When observing a typical comet approaching the Sun, we usually see a familiar set of features: a glowing nucleus composed of ice and rock, surrounded by a hazy layer of evaporating gas, possibly dust jets from active regions, and warm sunlight. These are the classic signs of cometary activity, phenomena we've documented countless times. Yet, the absence of these expected features was the first major warning sign. Celestial bodies from outer space should be unstable, continuously shedding ice and gas. But this comet is not like that, suggesting it is composed of denser material and is more solid, like rock or metal, or perhaps an entirely different substance. Yet images of comet haze reveal an object that appears almost deliberately designed. This celestial body exhibits geometric regularity. Naturally formed objects should not exhibit such regularity. We typically expect to see lumpy structures, potato-shaped formations, common in asteroids and comets. Atomic nuclei appear as smooth planes to our eyes. Its features can only be described as meticulously engineered. 3 distinct appendages extend almost perfectly from the central body at 120-degree angles, forming a tripod-like configuration, ruling out any known random stacking process or cosmic impact. This tripod form holds significant meaning from an engineering perspective. It represents one of the most stable structures, an ideal design for ensuring the stability of an instrument platform. Each arm extends approximately 12 miles in length, stretching for miles, tapering toward their ends, displaying mathematical elegance. Yet this very precision makes the discovery unsettling. Spectral analysis reveals the 3 appendages are composed of distinct materials. The main body's albedo matches carbon-rich substances, meaning it absorbs no sunlight and appears dark. Yet the 3 extended R-like structures exhibit extremely high albedo, nearly mirror minus-like. They scatter over 90% of solar radiation with an efficiency comparable to polished steel or advanced solar panels. This combination presents a core analytical challenge. Black bodies absorb heat, while reflective surfaces dissipate it, This suggests a highly exhaust functional design, potentially for thermal regulation, solar cell energy harvesting, or even propulsion systems. This morning, Dr. Sarah Chen of MIT's Knight Institute released detailed photometric research. Her conclusion cuts to the heart of the matter. Any known natural mineral structure exhibiting optical perfection at 200 nanometers would possess reflective properties indicating manufacturing precision far exceeding that of natural crystals. Let's calmly consider this concept. We're discussing an object in the vastness of interstellar space, potentially billions of years old, located in a galaxy we may never fully explore, that exhibits manufacturing precision beyond natural formation. As scientists, we're trained to avoid sensationalism and remain committed to ruling out all conventional explanations. This process of elimination is the very essence of the scientific method. The scientific debate over its nature has been settled. All credible evidence points to the conclusion that it is a natural comet. Though the Harvard professor's dissent remains non-mainstream, it has spurred deeper research. The most valuable legacy this visitor leaves us is heightened confidence. Next-generation Sky-survey telescopes are projected to discover several similar interstellar visitors annually. This will inaugurate an entirely new field of research, interstellar astrophysics. Scientists estimate trillions of such objects may exist near our solar system alone. They silently transport matter between star systems, potentially including organic molecules and even precursors to life. This interstellar exchange of materials suggests the seeds of life may be scattered throughout the Milky Way. As we watched it fade from our observational field of view, we couldn't help but ponder our place in the cosmos. Earth is not an island, nor is the solar system an isolated fortress. Through countless interstellar messengers like this, we are intimately connected to the entire Milky Way. It witnesses the birth and death of stars, the formation and dissolution of planetary systems, and the cosmic scale cycling and regeneration of matter. Its arrival brings not only precious data but reignites our awe for the universe. As it finally vanishes beyond our observational horizon, the scientific questions it leaves behind will continue to inspire humanity's quest for the unknown. In the endless cosmic voyage, this may be just another ordinary encounter. But for us, it represents a significant expansion of humanity's cognitive frontier. Its journey will continue toward the next unfamiliar star system. Carrying the faint imprint it took from our solar system, it will drift eternally through the Milky Way. Meanwhile, we continue to gaze at the night sky, awaiting the arrival of the next interstellar messenger. For each such encounter represents a leap forward in our understanding of the cosmos. This journey is far from over. It may only just be beginning. As we probe deeper into the cosmos, more mysteries will undoubtedly emerge. Every answer brings new questions. This is the very essence of exploration, a journey without end. If you enjoyed this journey through the mysteries of the cosmos, please like and share this video with other curious minds. Subscribe to the channel and turn on notifications so you won't miss our next exploration. Whether delving into the heart of a black hole or tracking the traces of dark matter, science awaits our discovery, and the greatest revelations always lie ahead. Thank you for diving into the vast mysteries of the cosmos with us. Remember, questions never exhaust answers, they only lead to more questions. And that is precisely why the journey is worth continuing. We may live within a vast cosmic void, but this realization is not a wall isolating us. It is a new window opening before us, through which we glimpse a more authentic, more complex, and ultimately more worthy universe to explore.